Hi all. So for discussion 6, I chose to use the original 8 Disney princesses as my population sample. Um, Also, a note before I started this, I didn't realize that going through everything would take as long as it did, so that's why it is not turned in at 11 o'clock, but I've gone through it and I hope it's fully done. So I said, let's suppose our population consists of the original 8 Disney princesses. So if you go on the Disney Princess Wikia, these are the first 8 when the Disney princess thing was started back in 2000, and it has now since expanded. So there's a lot more princesses, but I felt like the sole 8 were a good smaller population to use for this. So I said we want to observe how many princesses from a sample of 2 will have blonde hair. So Aurora and Cinderella, these 2 in the middle, fall into the categories. So going over the definitions, simple random sample is a sample, drawn in such a way that each combination of n individuals from the population has an equal chance of selection. So a sample is a subset of the population, and the population is the entire group of individuals we hope to learn about. So the probability model is a collection of all possible values and each probabilities that they can occur, I'm assuming I meant to put. X-axis are the possible values of the random variable, and the y-axis are the probabilities of each outcome. And all the probabilities should add up to 1. So I worked all this out beforehand, and as I found out, it took me way too long to model in a video. So here we are. So I have the picture again, and here I've listed that the population is the 8 Disney princesses, and the random sample size is of 2, and we need to assume that each princess has an equal chance to be drawn. So this is my I don't know what I was going to say. So I went through and listed each princesses on the top: Jasmine, Snow White, Mulan, Aurora, Cinderella, Pocahontas, Belle, and Ariel, and I went through the possibilities. So I found out there was 8 possibilities when I listed all of them out. So I started with Jasmine and then went through each princess, and obviously there's no block for Ariel since she's already been paired up through here. So then after that, I went ahead and collapsed this chart and put it over here so you can just see all of them in a nice area. So what I wanted to look at was the number of princesses with blonde hair. So I went through and found the number of each, and then found the mean, median, and standard deviation of each of those. So the median was 0, the mean was 0.5, and the standard deviation was 0.58. So the mean is bigger than the median, so it's skewed right, and you can see peek over here. So I made a probability chart and listed the number of princesses that I was looking for that had blonde, and then the number that met the criteria of this chart. And we see that the only time that there was 2 princesses that had blonde hair, that only happened once, since Aurora and Cinderella can only be paired once, and the amount of times that 1 appeared was 12, and 0 blonde princesses happened was 15. So I found out the probability of this, and all of these probabilities add up to 1. So then I went and made my histogram. Sorry. And we can see that, as I said, it would be right skewed, and that it shows who has the least. So then I didn't use this data to find these, I can't think of the words right now, but so this is where the mean would be, and then how the standard deviation sets out. I didn't use this. I followed what Professor Barron said and went through and found the standard deviation like the book talked about and the mean. So I went through and multiplied these and then added them up to get the mean, which we can see that doing it this way, the mean here and here were pretty close. And then I found the differences between each and then squared those and then multiplied the square number times the probability to get this, and then I added them up for this, and then I found the square root to find the standard deviation, which was 5.6, and 5.8 of this, the standard deviation of this data was 5.8. So we can see they're relatively the same. So the triangle where it's pointing to is about the 4.9, and then I put the lines out to each side to signify where the standard deviation would be. Okay, so on to the next part of the discussion post. Process of estimating a probability distribution empirically. 1. List the members of the population and assign each individual a random number. 2. Determine which individuals are in each sample by picking out those with the smallest random number in each trial. For this, we will use n equals 2, since I'm looking for 2 blondes. 3. Make a probability distribution for the data. Simulation, a process that mimics reality by using random numbers to represent outcomes of real events and consists of several trials. In my case, we used 45 trials. Note, in these types of situations, the mean can be referred to as the expected value. So, randomly select 2 princesses that would be blonde. Step 1. Assign random number of each princess listed. So I list out the princesses: Jasmine, Snow White, Mulan, Aurora, Cinderella, Pocahontas, Belle, and Ariel, and listed the trials on this side, so down to 45. And then I won't be able to click and show you because I copy and pasted my values so I wouldn't mess it up with an calculate now button, but Professor Barron showed us to use equals and then rand, R-A-N-D, parenthesis, to get the random number, and she liked using it times 1,000 to get bigger numbers so we don't have to work with decimal points. So I did that, and I dragged it across to get the first set of numbers, and then I dragged it all the way down, since I had to redo it because I messed it up, because I hit auto calculate or calculate now and had to redo the whole thing. Fun. But so I dragged it all the way down, and then I made sure to copy and paste the first row to the values, and then I hit calculate now to find the rest of them. So as we can see, I have all these different values. So Professor Barron showed in one of the videos to select the row and then go to conditional formatting, and then top bottom rules, top bottom 10 items, and I did 2, and then I did green fill to get the highlight over the smallest 2 numbers. She also mentioned that she liked to notate which individual we were looking at, so I bolded and underlined, and then I found that I was misreading, so I highlighted the middle row so I could be easily transferring and looking over and making sure I wasn't missing anyone when I was doing the count. So I did that, and I copy and paste, or I did this and I hit this paint copy formatting from one location and apply it to another, and did it to the next row, and went through and did that for each of the 45 trials. Took longer than I thought it would, but here I am. And so the next step was to find each number. So I just went through and looked, and I think I had 2 2s and then more 1s and even more 0s. So, um, so then I counted them, and then I skipped the step of showing it, but step 3 is create a probability distribution, count the samples with each outcome. So I can do this quick right here, like equals count if, and then go here, and then, well, I need to add, and then say 0. And then it was 25 zeros. I'm going to go in and put the dollar signs so they stay, so I can drag down and then actually change this to here so I can get 25 0, and then I'm going to drag it down, or I'm just going to, yeah, I'll drag it down 3 times and then edit the rest of them. So, well, never mind, don't listen to that. And then same thing, count if, and then the range, I guess I could have done that. Whoops. It's fine. And then 1, and then count if, just the range again. This is taking extra time, I know. But, and then 2, and we can see that I had 2. So 25, 18, and 2. So then I went ahead and did divide by 45 for each of them to get the probability, and then made sure they totaled 1. And so then I went ahead and found the mean, or the expected value, and then the standard deviation. And just like the last time, I went through and found it like Professor Barron. So took these, times it to get these, added this up to get the mean, and then subtracted or I got the differences between. So subtracted this from the mean, or the mean from this, and then squared this number to get the variance, and then here's the sum of that, and then I found the root to find the standard deviation. So here's my histogram. We can see that it is right skewed, so the empirical probability distribution for the number of blondes in the sample. And we can see that 0 has the most, 1 has the next most, and 2 has obviously 2 or 0.04 or 4%. And so the triangle is pointing to where my mean lies, so roughly 0.49, so about 0.5. So right there, I think it's a little high. So we can bump that down, and then both lines out to the side show the standard deviation. And I did calculate the average or the mean and the standard deviation for this set of data, so it is relatively close. It's within 0.05 of each other. So thank you for watching my video. I hope it was easy to follow. I know I didn't show a lot of stuff since it would have taken forever, but sorry this video got a little long too.